Now synchronization concept is over. We have completed it. Now let's move on to inter-thread communication. So let me give you an example. Okay, so suppose this is me, this is O1, this is O1, correct? And I am very hungry, but the food time is still remaining is 30 minutes. Time is still remaining 30 minutes, and currently it is 9 p.m. for example. So at 9, I know it is 30 minutes, but again at 9:01, because I am very hungry, I go and check. I come back. At 9:02, I again go and check. Again come back. At 9:04, I again go and check. Again come back. At 9:05, again go and check. Again come back. This happens till 9:30. I got the food, and now I can continue with my other work. So till this whole time, I am doing nothing. I am doing nothing but just going and coming back, going and coming back, and I am using the resources. I am using the resources. Okay, what is a better way? Better way is, this is some other process. For example, T2 is performing this O1 process, correct? This is some other process, correct? So what is the better way is, when I go at the first time, I use a method known as a wait method. I use a method known as a wait method, and when I am using a wait method, after that I will go to a waiting state. Now T2 is responsible for completing the O1 task. So T2, once completing the O1 task, will use a notify method. Using this notify method, I am in the waiting state, so I will get a notification that the task is complete. I can come back and resume my execution and other work. Correct? So this whole time I was wasting time on a single job. But now, using the wait and notify methods, these two threads are communicating with each other. Okay, T1 is saying to T2 that I will wait, just when the work is over, just notify me. And T2 is saying, okay, I will notify you whenever the work is over. Okay, so this was a simple analogy to explain you how inter-thread communication works using wait notify, and there is one more method, notify all. So if there are many threads to be notified, so notify all. Correct? So let's begin now. So threads can communicate with each other by using wait, notify, and notify all methods. The thread which is expecting updation is responsible to call wait, and it will enter into a waiting state. So in our case, T1 was actually expecting the updation from O1, correct? If food is prepared or not. So T1 will call the wait method. T1 will call for the wait method and will enter into the waiting state. Fine. Next point is the thread which is responsible to perform the updation. So T2 is responsible to perform the updation. So after completing a job, it will call for a notify method. This notification will be received by the waiting thread, and it can continue its execution. Fine. So it will be received by the waiting thread and it will continue the execution. So we are adding a waiting state. Fine. Next point. So this is a question. So where wait, notify all methods are present? This is a very, very important question. Just think, is it present in object class or in thread class? Till now we have seen most of the methods are present in thread class, and I will give you one more hint, that wait, notify all methods are only used by threads. So are they present in object class or thread class? Just think about it. The answer is object class. Now you will ask, how is this possible? That since they are only used by threads, why do not we keep them in thread class? Why are keeping them in object class? The reason is actually very simple. So this is an object, for example array list. This is an object, for example linked list. Correct? This is an array list object, this is a linked list object. Now T1, T2 can call wait and notify methods on these objects as well. Am I clear? So T1 can call the wait method on this object, and T2 is responsible for some updation. It will call a .notify method. Okay? Is linked list or array list present in the thread class? No, they are not present in the thread class. So how will they use wait method, notify method, and object notify all method? Since the reason being, threads can call these methods on any Java object. It is not bound that they have to call the methods on thread object only, thread class objects only. No, they can call the methods on any Java object. So these methods are present in the object class. Why? Because there is only one class, there is object class, whose functions can be accessible to any Java objects. Correct? This line is important, that is any Java object. Threads can call these methods on any Java object. So these methods are present in object class. This is very confusing. So, and this question is asked many times in the interviews. So where wait, notify methods are present? So they are present in actually object class. And what is the reason? Because threads can call these methods on any Java object. Where it can be array list, linked list, tag queue, anything. So these methods are present in object class. Okay, not in thread class. Fine. The next point, to call wait, notify all, methods on any object, thread should have the lock of that object. That is, thread should be inside synchronized area. Now, if I want, this is my object, correct? And T1 wants to call dot wait method. So to call dot wait method, it needs the lock of this object. It needs the lock of this object. To call the dot wait method, it needs the lock. So if it needs the lock of the object, that means it has to be inside the synchronized area. That means it needs to be inside the synchronized area. Correct? So to call these methods, now T2 comes, T2 will complete work, and it will also have dot notify. So it also wants the lock of that object, or it also needs the lock of the object to call these methods. Therefore, thread should be inside the synchronized area. Okay. The next point is, hence we can call wait, notify all methods only from the synchronized area. Otherwise, we will get illegal monitor state exception. So this is an important point. Which exception we will get if we call wait, notify all outside the synchronized area? We will get illegal monitor state exception. Okay, it needs to be called only inside the synchronized area. That is wait, notify all methods. So what is the next? If a thread calls, so what is next? If a thread calls wait method on any object, it immediately releases the lock of that particular object and then enters into the waiting state. Okay. If a thread calls notify method on any object, it releases the lock of that object, but maybe not immediately. Except lock and notify all, there is no other method where thread releases the lock. Let's see now these 3 points. What are these 3 points? So what it's saying is, I have O1 and T1 needs to call dot wait method on it. So it needs the lock of O1, correct? So it gets the lock of O1. After this, as soon as it calls wait method on it, it needs to release this lock. It will go to the waiting state. Before going to the waiting state, it needs to release the lock. The reason being, T2 after completion needs to call dot notify method. Am I right? T2 after completion needs to call dot notify method. But to call dot notify method, it needs the lock of the O1. So if T1 does not release the lock of the O1, how will T2 get it? So before going into the waiting state, T1 releases the lock of the O1. So that after that, T2 will get the lock of O1 and it can call dot notify method. Okay. So T1, as soon as it immediately after using the dot wait method, it releases the lock. But T2 might have some more work. So after notify, it may not immediately release it, but it also has to release it. The reason being, why it has to release the lock, it is also very simple. So, because now T1 notification will go to T1. T1 will execute the remaining code, his remaining code. So his remaining code to execute the remaining code, and he is in synchronized area, so he will need the lock of O1 again. So this is the reason why this lock has to be released by these T1 and T2 threads. So except wait, notify all, there is no other method where thread releases the lock. Okay. So these are the wait method. It throws the interrupted exception. Okay. This is wait method. For this much time I will wait. For this much time I will wait. And this is the wait method for the stricter times, that is long millisecond and long nanosecond. This is the notify method and this is notify all method. So this was inter-thread communication, means that using wait, notify and notify all methods, our threads are communicating with each other. Okay. The important points here are, first, they can only use dot wait or this wait method or notify all method from the synchronized area. Okay. They need lock of the object. As soon as the wait method or notify method is called, the lock of the object needs to be released, as other thread will need this lock. So the lock of the object needs to be released at that particular moment only. Okay. Immediately it needs to be released in the case of wait, and after some time in the case of notify. Fine. These are the important points in wait, notify and notify all methods. Okay. So this was inter-thread communication. Now we will see another topic known as daemon threads. So what are daemon threads? This is a very simple topic, and this will be completed very fast. A daemon thread is simply a thread that has no other purpose in life than to serve others. For example, we will have garbage collector. So threads which are executing in background are known as daemon threads. So garbage collector is an example of a daemon thread. So whenever, for example, my main is working and memory is full. Let's say for just an example, memory is full. There are a lot of garbage in my code. So the memory is full. So JVM, what it will do, it will go to the garbage collector and say, see, go here and collect all the garbage. So the memory will be reduced. Okay. So garbage collector will go and it will help the main thread. Garbage collector will go and help the main thread. Okay. So the threads which are executing in background, the threads that has no other purpose but to serve others are daemon threads. Normally, daemon threads run with a low priority, but based on requirement, priority can be increased. So normally the garbage collector priority is 1, but in this case, JVM will increase the priority to 10. Okay, so the maximum priority. By default, main thread is always a non-daemon thread. Main thread is always a non-daemon thread, but this is an important point. By default, main thread is always a non-daemon thread. And for all the remaining thread, daemon nature will be inherited. For example, parent is a daemon, so child is also a daemon. If parent is a non-daemon thread, then child is also a non-daemon thread. In all the examples that we are seeing till now, we have main thread and a child of main thread, correct? So this is a non-daemon thread, so this also will be a non-daemon thread. Okay, let's just rub these things out for you. Let's see. Okay, so the next point is whenever last daemon thread non-daemon thread terminates, automatically all daemon threads will be terminated irrespective of the position. Now what is the purpose of a daemon thread? The purpose of a daemon thread is to serve a non-daemon thread, correct? Now if non-daemon threads are dead or they are terminated, so what is the purpose of daemon thread? There is no other purpose left, so they are also terminated automatically. Okay, if non-daemon threads are terminated, then daemon threads are terminated automatically. The reason being, daemon threads have only one purpose, that is to serve non-daemon threads. Okay, so this is public boolean is daemon. It is used to check whether a thread is a daemon or not. Okay, if you want to check whether your thread is a daemon or not, just use this method, public boolean is daemon. Public void set daemon. If you want to set a daemon, if a thread a daemon or a non-daemon, it is used to set a thread daemon or a non-daemon depending upon boolean value. If boolean value is true, if I do t1 dot set daemon true, so now t1 will become a daemon thread. If I go t1 dot set daemon false, so now it will become again a non-daemon thread. Okay, so let me rub this because it is coming in way. Next is this method must be called before the thread is started, else it will give runtime exception, that is illegal thread stick exception. So before dot start, this method will be called before dot start. If it is called after dot start, it will give an exception, illegal thread state exception. Okay, so a question: is it possible to change daemon nature of a main thread? Just think about it. Is it possible to change a daemon nature of the main thread? Just think, just pause the video and think. So the answer is no. It is not possible to change the daemon nature of a main thread because it is started by a JVM, and the nature can only be changed before the start, before it started. It is started by JVM and the nature can only be changed before it started, so we cannot change the code, correct? Before the start method, it has to call this method, that is the set daemon, if you want to change the nature of a thread. Okay, but the main is called by the JVM, started by JVM, so we cannot do anything. So it was daemon threads. So this was completely, so this now here completes our multi-threading. Okay, what we have learned many things. So we started with what you say, we started with the difference between process-based multitasking and thread-based multitasking, correct? Process-based versus thread-based. Then what we see there are two ways of defining a thread, that is extending a thread or implementing runnable interface. Who is better? Implementing runnable interface is better, and you know the reason for this. Okay, we have seen the priorities of the thread, we have seen constructors of thread. Okay, we have seen the difference between start method and run method. Okay, then what we see, we have also seen how to get a name, how to set a name of a thread. Okay, we have seen join method, yield method, sleep method. Okay, then after that we have seen the synchronization complete, and then inter thread communication complete, and the daemon threads. So here in join method, just take care of the deadlock situation. Okay, in synchronization also deadlock can occur, so precaution is better than cure. So what you have to do, you have to just take care in these two cases about the deadlocks. And how synchronization occurs? Synchronization is done with the help of log, but this log programmers do not have to do anything. JVM will do it at the background. Okay, so this was multi-threading as a whole concept. Thank you.